questions ready. Question 1 was briefly explain how a dry sample of chlorine gas can be prepared from manganese 4 oxide. The word was explain. One time I told you that when a question says explain how a gas can be prepared, we have three words. We have explain, we have describe, and we have state. So when a question says explain how a gas can be prepared in the laboratory, it wants you to, whatever point you give a reason. That's usually what the question wants when it says explain. For example, many of you did not get all the marks, and I'm going to tell you the reason. Now, you should have said, place manganese 4 oxide into a flask. Place manganese 4 oxide into a flask. You can combine all this and say, place lumps of manganese 4 oxide into a flask because it is a solid. We have always told you this. Now, the reason why manganese 4 oxide is put in a flask is because it is a what? A solid. So place manganese 4 oxide lumps in a flask because it is a solid. I hope you people are noting down something. So you are explaining now. You have given a reason why you have put manganese 4 oxide in a flask. Okay? Then pour concentrated hydrochloric acid down the thistle funnel because it is a liquid. You get that? Yeah? Now you are explaining why do you put concentrated hydrochloric acid in a flask? I mean in a thistle funnel. Why don't you put manganese 4 oxide instead in a thistle funnel? So that is the reasoning. Pour concentrated hydrochloric acid down the thistle funnel because it is a what? A liquid. So liquids are put in the thistle funnel. Okay? Heat the mixture in the flask. Heat the mixture in the flask because the reaction cannot take place at room temperature. So if there is a reason, please give it there. You will be explaining. Now, after heating the mixture, definitely effervescence occurs involving a greenish yellow gas. Although we don't mark this, it is an observation. Effervescence occurs, giving off a greenish yellow gas. The greenish yellow gas is chlorine. Note that in this question, diagram was not required. Diagram was not required. So we are just explaining. Okay? Now, after effervescence of chlorine gas has been given out, the next step will be to remove fumes of hydrogen chloride gas. Don't leave out anything. Okay? So we say the chlorine gas is evolved together with a small amount of hydrogen chloride gas, which is removed by passing it through a wash bottle containing water. So you will say chlorine gas is then passed through a wash bottle containing water to remove hydrogen chloride fumes. Most of you wrote that. So the problem is you are not giving the reasons, eh? That's why you lost out some marks. The gas is then, now you dry the gas, eh? The gas is then dried using concentrated sulfuric acid. Hmm? The gas is then dried using concentrated sulfuric acid. There is a reason here why we use concentrated sulfuric acid to dry chlorine gas. Who can tell us? Why do we use concentrated sulfuric acid to dry the gas? Remember, the question is explain, so you need to give a reason there. Someone tell us. Lisa. Lisa, I told you I hate people who I call and they don't say anything. I will be removing you, by the way. Hmm? So, the gas is dried using concentrated sulfuric acid because chlorine gas is acidic and does not react with concentrated sulfuric acid. That is the reason why we use concentrated sulfuric acid to dry the gas. And since we are explaining, then we are supposed to give that reason also. The gas is dried using concentrated sulfuric acid since it is acidic and does not react with sulfuric acid. Because if the gas is acidic, it cannot react with sulfuric acid, which at the same time is also an acid. Then finally, the gas is corrected by downward delivery because it is denser than air. And that is the end. So my comment is, when a question asks you to explain, please, if there is a reason, you should always give it. If there is a reason, you should always do what? Give it. Then part 2 is saying write the equation. So if they don't tell you to write the equation, then you are supposed to write it in your explanation. But here, this is an independent question asking you to write the equation. So the equation is between manganese 4 oxide plus hydrochloric acid, and we form manganese 2 chloride plus water plus chlorine. To balance, I told you, begin by balancing oxygen. These are 2 oxygen atoms, and this originally it was 1. So you must put 2 on water to balance oxygen. And when you put 2 on water, the hydrogens become 4. You will need to put a 4 on hydrochloric acid to balance the hydrogens. And that will be the equation. Then also we may ask you why chlorine is prepared in a fume cupboard. The answer is, it is poisonous. Most of you agree with me that you cannot stand that smell of jik, which contains a lot of chlorine. Describe test for chlorine gas. That one we saw it. We just say it is a greenish yellow. It is a greenish yellow gas that turns moist red litmus paper. The answer is here. Test for chlorine. Okay, it is here. We saw it on page 247. It is a greenish yellow gas which turns moist blue litmus paper red, and then breaches it. State what would be observed if red flowers were dropped in a gas jar containing chlorine gas. If red flowers were dropped in a gas jar containing chlorine gas, what would be observed? The red flowers, many of you are saying they would be bleached, but what do you mean by them getting bleached? And colorless, it is very hard to find something that has no color, but they will appear to be white. So the best answer there would be the red flowers will change color to white. They will lose color and they will appear to be white. They will lose their red color. Okay, so the red flowers will lose their red color and turn to white. Then the equation is going to be the same equation for the dye. In that case, by the way, for your information, in that case, our dye is a red flower. So you don't have to put a red flower here. This becomes the general equation. Okay? This becomes the general equation. So this is our red flower. Don't put the red flower again because they are colored. So the general equation is this. Dye plus hypochlorous acid giving us hydrochloric acid plus, now this dye and oxygen, it is one thing, so it should be put in bracket together. Some of you were adding and not putting there the bracket. That means you will be adding the dye, then adding oxygen also, but it is one thing. So put it in bracket. Those of you who didn't put it in bracket, your answer is supposed to be wrong. You're supposed to get 0 there. So this is the equation for the red flowers losing color and turning to, we allowed all answers. You can put either colorless or white. We shall allow it. It is okay. They lose their color. Also, many people were saying they return to colorless. That one is okay. So dye plus hypochlorous acid giving us hydrochloric acid, but I'm insisting this dye plus oxygen, it should be one thing, so it should be in bracket. So check your work. Then from there I drew for you a simple diagram. You people, I'm taking a lot of time. I'm going slowly because I know how important this is. Make sure every point that I talk about here, you put it in your head properly. Questions will arise. So I drew for you a simple diagram and I think it almost looked like this. Identify the gas. That was part 1. You agree with me that the gas is oxygen. And state how the gas was identified. This was a very simple paper, a very simple assignment. How can oxygen gas be identified? Oxygen gas can be identified by introducing a glowing splint in a gas jar containing oxygen, or insert a glowing splint in a gas jar containing oxygen, and the glowing splint rewrites. The glowing splint rewrites. Then I had a problem with some of you writing the equation, because the question was, write the equation leading to the formation of oxygen gas. This chlorine water is already hypochlorous acid. You don't have to write this equation again. You don't need it. So when we say chlorine water, we are already talking about this. Don't write the equation again. So the equation leading to the formation of oxygen, I wanted this one. This is the answer I wanted. Only for 1.5. The equation leading to the formation of oxygen. Oxygen is coming. Remember, chlorine water is a mixture of two compounds. It contains hydrochloric acid and hypochlorous acid. But oxygen does not come from hydrochloric acid. In this case, it comes only from hypochlorous acid. So the equation I was interested in was this one, or this first one. That second one had no use there. But I encourage you to always remember this one. It is the simplest. Hypochlorous acid, when it is exposed to sunlight, it will form hydrochloric acid plus what? Oxygen. And that is it. State what is observed when chlorine gas is bubbled through a solution of cold dilute sodium hydroxide. We looked at that. We said it will form a pale yellow solution. And what is the pale yellow solution? The pale yellow solution is sodium hypochlorite. We could have also asked you to name the pale yellow solution. The pale yellow solution, we are insisting that it is sodium hypochlorite. It is formed alongside other compounds like sodium chloride and water, but all these compounds are colorless. So the observation that will be seen is sodium hypochlorite, which is a pale yellow solution. And the equation is right here. You can see it. Nothing changes. Chlorine plus sodium hydroxide, the product is sodium hypochlorite plus sodium chloride plus water. We said, or we are saying that the condition here is that sodium hydroxide must be dilute and cold. That's the condition. Sodium hydroxide must be dilute and cold. Any question from the work that I had given? Any question? Okay, let's continue. We ended when we had looked at reaction of chlorine and hydrogen, and we are saying the product when chlorine burns in oxygen, chlorine, it explodes, forming hydrogen chloride fumes or hydrogen chloride gas. If we ask for the observation, hydrogen chloride gas usually appears as white fumes. Usually appears as white fumes. Let us look at chemical properties of chlorine as an oxidizing agent. Chlorine is an oxidizing agent. If I were to ask you what is oxidation, remember we said oxidation is the addition of oxygen or removal of hydrogen from a compound or addition of electrons. That is oxidation. Oxidation has 3 definitions. Someone serious should be writing them now. Oxidation is the addition of oxygen or removal of hydrogen or addition of electrons. All those words mean one thing, which is oxidation. So chlorine removes hydrogen from many compounds. So if it removes hydrogen, that means it is oxidation. removes many hydrogen from many compounds, as well as accepts electrons from metals. The oxidizing property of chlorine is demonstrated in these reactions. For example, reaction with hydrogen sulfide gas. If we have chlorine and we add to hydrogen sulfide gas, chlorine removes hydrogen from hydrogen sulfide. So there it will have oxidized it. Eh? Please get my point. Oxidation is the removal of hydrogen. So if chlorine removes hydrogen from hydrogen sulfide, then it will have oxidized it. And we are saying it forms hydrogen chloride. When chlorine removes hydrogen from hydrogen sulfide, the product will be hydrogen chloride plus sulfur. Now, you know the color of sulfur, it is yellow. Eh? So sulfur is yellow and it is a solid. If this was a solution, then it would have been a yellow precipitate. But there is no solution there. This is a gas and sulfur is a solid. So we may ask you to state what will be observed. The answer is a yellow solid. Then the yellow solid is for sulfur, and also there will be white fumes of hydrogen chloride gas. I think that one has been understood. Chlorine is an oxidizing agent here in this case because it removes hydrogen from hydrogen sulfide. Okay, so we say hydrogen sulfide has been oxidized to sulfur, and chlorine itself has been reduced to hydrogen what? Sulfide. The one that loses hydrogen is the one that is oxidized. Okay? So we shall save the equations for senior 5, these equations. But for now, we can always remember this. Reaction with ammonia. Now, still, chlorine will remove this hydrogen from ammonia. And when hydrogen is removed, you remain with nitrogen and hydrogen chloride. So still in this case, chlorine is an oxidizing agent. It oxidizes ammonia to nitrogen gas, and itself is reduced to hydrogen chloride. Okay? I think you are getting my point. The hydrogen chloride produced reacts with excess ammonia to form ammonium chloride. This one you remember when when hydrogen chloride comes in contact with ammonia. Actually, this is the test. We said this is the test for ammonia gas, that it forms dense white fumes with hydrogen chloride or concentrated hydrochloric acid. I think you remember that work. Yes, I think you remember. So this is the equation. Let us go with this equation. When chlorine reacts with ammonia, leave around the excess, you form nitrogen gas and hydrogen chloride. So chlorine will have oxidized nitrogen, will have oxidized ammonia to nitrogen. By removing hydrogen, it has oxidized it. Oxidation of iron 2 to iron 3. Before I say anything, I have to tell you and warn you that this reaction is very, very, very important. Oxidation of iron 2 compounds to iron 3. That work is usually done by chlorine. If you have an iron 2 compound, listen, if you have an iron 2 compound, for example, iron 2 chloride, or iron 2 nitrate or iron 2 sulfate, and you bubble chlorine through that solution, or you add chlorine in that solution. We are saying that solution will be oxidized to, it will be oxidized to iron 3. If it was iron 2 sulfate, it now becomes iron 3 sulfate. So chlorine accepts electrons like other oxidizing agents and is converted to chloride. This should be chloride ion, and this is the equation. When an atom gains electrons, it gets a negative charge. So chlorine plus 2 electrons, we get 2 chloride what? We get 2 chloride ions. The electron that the chlorine accepts is supplied by a reducing agent, which in this case is iron. So the reducing agent is iron 3. Now I don't want us to overlook at that equation. We can concentrate on this one because we have not studied ionic equations. We shall study them with time, probably when we reach at school, because they have some technicalities. But we can go with this. When chlorine is bubbled through, now all iron 2 compounds, their characteristic color is green. Please note that somewhere that iron 2 compounds, their characteristic color is green. Iron 2 compounds have a characteristic color of green, and iron 3 compounds have a characteristic color of brown. Note, iron 2 compounds are green and iron 3 compounds are brown or yellow. Iron 2 compounds are green and iron 3 compounds are brown or yellow. Okay? So when chlorine gas is bubbled through a pale green solution of iron 2 chloride, we are saying it changes to yellow. So the most important question we usually ask here is state what is observed when chlorine is bubbled through a solution of iron 2 chloride or iron 2 sulfate. And we are saying the answer is a pale green solution. Pale green solution will be for iron 2 chloride. Will change to yellow, and the yellow solution will be for iron 3 chloride. Okay? Take note of that. Iron 3 chloride is yellow, then iron 2 chloride is what? Green. So chlorine oxidizes iron 2 chloride to iron 3 chloride. That's why we say chlorine is an oxidizing what? Agent. Okay? It changes to yellow due to formation of iron 3 chloride. Okay? When sodium hydroxide is added to this solution, this one, let's leave it for practicals. For us, let's stop here. Let us stop here. That is the observation we need to know. When chlorine is bubbled through a solution of iron 2 chloride, it changes to yellow. Why does it change to yellow? Due to formation of iron 3 chloride. So we have iron 2 chloride in the equation plus chlorine, it forms iron 3 chloride. And to balance the equation, remember this was iron 2 chloride and this is iron 3. You make chlorine an even number by putting 2 which makes chlorine atoms 6. But when you put 2 on iron 3, then it will necessitate you to put 2 also on iron 2 chloride. And that is the equation. So if this was iron 2 sulfate, then it would have formed iron 3 sulfate. So this is the general equation for iron 2 compounds, iron 2 compounds plus chlorine forming iron 3 compounds plus chloride ion. Reaction of chlorine with hydrocarbons, e.g. turpentine. So this is the formula for turpentine. Usually when we ask a question, we give you the formula. But I want to tell you, this question is very common. If you check around in the question bank, you'll find it in many occasions. So hydrocarbons, they are compounds that consist of carbon and hydrogen only. And we are saying when they react with chlorine, chlorine oxidizes the hydrocarbons by removing hydrogen. So chlorine removes hydrogen from hydrocarbons to form hydrogen chloride, and black particles of carbon are left. So we may ask you to state the observation when chlorine gas is passed over heated turpentine wire. Heated turpentine wire, you will get black particles, or you will form black particles of carbon. In all these cases, chlorine is an oxidizing agent. Most of the reactions of chlorine is when it is working as an oxidizing agent. You people, take note of that. Now, in this case, chlorine removes, we are saying it removes hydrogen from hydrocarbons. So the procedure: form a little turpentine in a dish, dip it into a filter paper, and drop the filter paper in with turpentine in a gas jar containing chlorine. All this is just confusion. You only need to know the observation. We are saying the observation are black particles of carbon, and the equation is here. This is the formula of turpentine, and most of the time when we ask the question, we give you the formula. So turpentine, write in your notes there that turpentine is C10H16, and when it reacts with chlorine, it forms, this is turpentine. It can be a solid or liquid. Turpentine wire, turpentine liquid plus chlorine, we get carbon. Carbon plus hydrogen chloride. So chlorine oxidizes turpentine by removing hydrogen. Remember the definition of oxidation. Oxidation is the removal of hydrogen. So please, this is very important. So chlorine removes hydrogen, it forms hydrochloric acid plus carbon. To balance, the carbon atoms here are 10. So you should also put 10 on carbon. Okay? And the hydrogen atoms this side are 16. You put 16 on hydrochloric acid. And then chlorine will become 16. You put 8 on chlorine to make it 16 also. So the hydrogen chloride, when it appears, it will always appear as a white fume. So in the observation, you can also add black solid particles of carbon and a white fume of hydrogen chloride. I want us to end here for today. I want to go very slowly. Next time, we shall look at displacement reactions of chlorine. When we come to look at displacement reactions of chlorine, I want you to come when you have revised reactivity series, because we shall be using the knowledge of reactivity series. I now invite questions if they are there.